Hey guys, Mr. Mises here, and in this video I'm going to be talking about integrating, integration using natural log functions. So I've got the log rules up here for integration. Notice here that even though when we took the derivative of ln of absolute value of x, it really didn't change the derivative at all, but when we do the integral, it does in fact make a difference between what we get in my integration, and it does make a difference, okay? And that's because of the domain restrictions on the antiderivative. We got to make sure that in our f prime function right here, in our f prime function right here, we got to make sure that x is not negative, because if x is negative, then in my derivative, in my antiderivative, it wouldn't be able to work, because ln can't be, the negative can't happen inside the ln. So we got to make sure that when we take the antiderivative 1 over x, we have to get ln of absolute value of x. So we got to put the absolute value in my parentheses. So in general, the log rules are the integral of 1 over x dx is ln absolute value of x plus c. Don't forget my c. And then we can use the reverse chain rule version there. Basically, the derivative of the denominator, if that's in the numerator, then we know that that's automatically just ln of whatever in the denominator, just like we did when we did the derivative. So we're just going backwards, right? Inverse relationship. So let's take a look at a few examples here that I have. And sorry about that. So I'm going to zoom in here. Take a look at each of these. All right, so the first one here is -3 over x. Well, this -3 can come outside of my integration, and then I can go ahead and just integrate the inside, which is ln absolute value of x plus c. Don't forget the c. All right, let's skinny this down a bit. I don't like that thickness here. Okay, what about this one? Well, notice here that in the denominator we have p squared plus 1. So the derivative of that is 2p, right? That would be my derivative. Well, I already have the p part, so all I need is a 2 there. So I need a 1/2 out there to do my reverse chain rule. And so I'm just going to have 1/2 ln of what's in the denominator, p squared plus 1 plus c. All right? So there's an example of a reverse chain rule. All right, let's go to the next one here. We'll do 3 and 4. So notice here in 3 as well, I've got this case of a reverse chain rule. Little bit different here, because what's the derivative of the bottom? The derivative of the bottom is 3t squared minus 2t. Well, I have 9t squared minus 6t there, so I'm gonna have to factor out a 3. So I'm gonna factor a 3 out, and then I'm gonna have 3t squared minus 2t. Perfect. T cubed minus t squared. Excellent. This is kind of like our hook right there. So we can use the reverse chain rule, and we'll have 3 ln of the absolute value of the denominator plus c. All right, and that's it. Okay, let's take a look at one last one here. Notice here for 4, the derivative of tangent, wow, that's a big dx. Jeez. The derivative of tangent is secant squared. So I already have the derivative up on top. That's my hook already, right? So I already have the hook here. So all I have is the natural log of tan x plus c, because that's what's in the denominator. All right, and that's it. So there you go. There are 4 examples of using the integration rules for natural logarithms. I'll come back and look at some kind of different ones in the next video. See you guys.